Okay, we're in section 40 of the notes. What we're going to do is volumes of revolutions. What we've done before, what we did before, we did disk. And now what we're going to do is we're going to do a cylindrical shell. Certainly, let me just point out again, I lifted this picture from a textbook. This is a typical picture that you will see in a textbook. All right, what they draw a shell and they fold it flat. We will talk about that and I will read it to you. All right, maybe not verbatim, but I'll outline what this is saying. So then the problem comes, symbolically, what's the volume of that the box we just did? We'll go through that. But here's the problem: we need to go through examples. So one thing is to say what we're going to do. Then you say, oh, gee, leave it at that. But then we have to do examples. Students also find this difficult. The most important thing, though, is that you can visualize the object that we're looking for. What are we looking for? We're looking for a shell. What do? We cut the shell and we fold it flat. We're actually visualizing a box, which is much easier to deal with. All right, but we will go through examples. This will be a very short lecture. As we go through the examples, again, these were lifted from a textbook, just copied them, and I read just to show you what a textbook would look like. We're indicating actually it's a good idea to look at your textbook and read. All right, a lot of students, what happens to them in their education is there's no reading going on. I often think to myself is that's really a poor standard of an education when you don't read. You have to read. Now, some people say, oh no, I go to school because I don't want to read. I just want to be spoken to. I want someone to tell me stories, do this, do that. That is not an education, by the way. Really what's happening there, if you're just being spoken to, it's basically you're being trained at the lowest level. All right. So what we're going to say is please look at your book. All right. Now, granted, lecture is important. Was lecture a lecture where someone is storytelling? They're telling you what they're doing to do the problems, but you still need to be engaged enough where you're reading a textbook. So we'll go through a bunch of examples and then you'll be some homework and you're going to do a bunch of those examples as well. All right. And that would close it out. All right. What do you mean by close it out? Close out section 40 of the notes. After section 40, there are no other sections in this course. All right. But there's, certainly if you want to read further in my notes, you can. But once we get done with this lecture, we'll go to examples and then we'll be done and we'll talk about moving towards the final. Let me move to the whiteboard. And I'm going to try to visualize what they're giving me. But again, I'm going to read it to you. And let's just make sure you understand what I'm doing. I'm reading this. Volume revolution, the method of cylindrical shells. It's actually a method they call cylindrical shells. What are they looking for? Give me 1 second. I got to get my whiteboard to come on again. There it is. Finally came up. Needed to warm up. So we're doing the method of cylindrical shells. And this is a good method. I'm not going to say it's better than the disk method, but the bottom is the more options you have, the easier it is to do a problem. Sometimes a cylindrical shell is going to be easier than a disk. Sometimes a disk will be easier than a cylindrical shell. How do you know? Experience is only gained by your activity. It can't be someone tell you which one's going to be easier. You don't know that until you try. And when you try, you're going to get better at things. I guarantee that. I really do. People generally don't get worse by trying. But anyway, we're using the method of cylindrical shells. What does it say? You should now be familiar with the disk method. What do you mean by that? Attended the lecture, prior section, section 39. You watch me do the examples. You studied the examples. You studied the method. You tried supplemental problems on your own, and you're willing to now move over to new technique. So again, I'm going to say I like the disk method. So it's a really nice method. And that's where most schools stop. Like I remember I went to an AP seminar. This was for high school students. And the teacher said that, oh, they just do the disk method. They don't bother with the shell method. And the reason why they say that, all the problems that the students will be confronted with can be done by disk method. And I thought, yeah, it's true. They can be done by disk method. But it's nice to have options. And we want to give you the option. So we're giving you an option. It's not a more difficult option. It's just another option. So what do? What they do is they try to visualize what's called a shell. And this is an image of a shell for me. I'm seeing the shell. Now, if I looked at that shell, I'm going to say it almost looks like a can where the top and the bottom of the can has been removed. Then what do they do with it? They cut the can. They actually cut it and fold it flat. And if they were to do that, they would get this object over here. So they cut the can and they fold it flat. Then they want to relate it back to this thing over here. And what do? They're basically at the same thing. They're looking at a rectangle. They're still doing that. What would that be? Well, thinking about it, the differential is going to be dx. I know they're using a delta x. I'm just going to put down dx. Sorry about that. All right, let's talk about the other things in the object. The other thing in the object is the can's got a circumference. What's the circumference going to be? This thing when I fold it flat. That'll be the circumference. What's circumference? 2 pi r. What's the r? Well, let's look at it. The r is going to be the x value. That's all it is. So what's circumference? It's actually 2 pi x. That's done. Next up, what's the height of the can? Well, that's going to be this thing over here, the function's value there, f of x. What's the volume of that can? When I say the can, I'm talking about the material that's being used for it. Well, that couldn't be any easier. It's a box. So what do you get over here? Let's write this down. 2 pi x, that's this dimension, times this dimension, f of x, times d of x. That's just one of them. And then what are you going to do? You're going to add all those objects together over some interval from A to B. All right, we'll get there. All right, so I'm going to say over here is bottom line, volume of a box, length, height, width, length, height, width. All right, not bad. Here's the problem though. We need to do examples next. What are our examples going to be? Images where you're going to see a shell. When you see a shell, what are you going to do? You need to visualize the shell, fold it flat, and come up with those 3 dimensions. This, and this. Hopefully things will be very clear. How do they become clear? Visualizing the shell and visualizing that rectangle. As you probably know by now, I'm always seeing a rectangle. Why is that? Riemann sums. That's what I'm looking for. All right, we'll go to examples next, but right now we're done introducing a shell. Thank you.